Morning, YouTubers. It's like 4 a.m. here and finally have a day off, so I figured why not shoot some fun videos. So today's idea came from one of you guys, which is, can you use flux core wire, so just straight gasless flux core wire, and then use C25, which is a MIG mix, as a shielding gas on it to reduce spatter or to have some effect on it. So pretty crazy idea. I've never done it. I have no idea what's going to happen, but we're going to try it and kind of be mad scientists together and see what happens. So let's get into it. So today's unofficial sponsor is Quick Trip Coffee. Get yourself some, it's pretty good. Don't eat their sandwiches, oh, they're garbage. So what we're dealing with is we have flux cored wire, and this is gasless flux core, so it is not designed to be run with gas. For you home hobbyists that are unaware, there is numerous brands, numerous types of flux cored wire that is designed to run with shielding gas. That type of wire is commonly, the street term, welder term, is dual shield. Dual shield wire was created to essentially get higher deposition rates than self-shielded, to produce cleaner welds, so less chance of wormhole porosity, like is pretty common with the self-shielded wire. And it gives you the ability to have massive weld penetration on very thick steel. So essentially for 3/8 and above thick steel, very good process to use. Very reliable. It runs very similar to like 7018, so it has a slag peel and everything, even though it is gas shielded. Pretty interesting stuff. But the thought is that, well, why not use flux core wire that you can get everywhere and then run gas shielding on top of it in order to get the effects of dual shield in a home hobbyist welder. Now, the interesting thing is that, and maybe some of you are unaware, you can actually get dual shield wire in smaller than 0.045 wire. Like a lot of times people think dual shield wire only comes in very big wire that you don't have enough power on a little home hobby welder. But I have seen 035 flux core wire dual shield. So that is an option. If you want to weld thicker plate with gas shielding and get less spatter, you could always run that. So the fact of doing this is kind of more like an experiment. And I gotta do a full disclaimer. I have no idea what to expect. I haven't researched this. I have my thoughts on it. So I'll share those in a second, but let's do a little quick book learning. I promise only like a minute or two, and then we're gonna actually do this and do a cut and edge and see what happens. So in front of us, I have 024, just standard hardwire, short arc MIG wire, and then obviously a flux core wire. When you use bare wire with the MIG process, you typically either use 100% CO2 or something like C25, which is 25% CO2, 75% argon, and that's generally the preferred mix. With self-shielded wire, you don't use any shielding gas, and then with dual shield, you use either like CO2, C25, or a specific blend to whatever wire you're using that they recommend, but that's, similar shielding gases. And I want to mention that using shielding gas with a process like self-shielded wire, I have a feeling is going to create differing results. And what I mean by that is CO2 itself arguably qualifies as an active gas. Like the higher the percentage of CO2, it has an effect on the arc. It actually increases the voltage in the arc gap and increases heat input. Okay, well, using something with a decent amount of CO2 on a process like self-shielded wire, I have a feeling may actually increase the heat input into the weld, which may not be desirable. So that's, problem number one. Problem number two is, and it's something that's often overlooked, is that your filler wire, like this bare wire, has a certain specification for the weld testing parameters. So like tensile strength, Sharpie V-notch testing, like all these numbers, all this information, right? That is assuming an atmosphere of either, say, CO2 or C25. Well, when you start adding additional things into your shielding gas, like say oxygen, which is somewhat common, low percentage of oxygen, hydrogen, any number of like other gases that are active gases, you can change the test results of the wire that you use. So in layman's terms, your weld can become more brittle, less brittle. The tensile strength testing can change. The grain structure can change. Any number of things can change, which is why, you know, as a disclaimer, it probably isn't the smartest thing to go and weld anything critical, doing something like what I'm going to do here, where you take a known, reliable, tested process, introduce a variable that could possibly change the weld that's deposited, because honestly, who knows what this is really going to do. I mean, I'm going to do a cut and etch that we'll look at to get an idea of at least, did it change the penetration? Did it, like, we'll get an idea of that, but we don't really know. Like, for all we know, the tensile strength could drop significantly because the grain structure is extremely poor. We don't know. So this is, you know, kind of for a fun experiment only, and not so much to actually create a reliable, you know, home hobbyist, poor man's dual shield per se. And speaking of that, I don't know why you would really do this. And the reason is that a spool, like this little box is a 2-pound spool of self-shielded wire. It's like, I think they're cost like 20 bucks now or something for 2 pounds. Bare wire like this is so much cheaper, probably half the price. So using this wire and then on top of it, adding in a shielding gas, your weld is going to cost a lot of money, far more probably than stick would be. So it's definitely not a poor man's dual shield. So again, I don't know that this would really be the smartest thing to do, but that's not the point of this video. The point is to play mad scientist and see what happens. So with that in mind, let's actually set up and run it and see what happens. Here's the initial settings: 18.8 volts and 360 inches per minute for wire speed. In the case of metric, I believe it's 9.14 meters a minute is what you should be aiming for. Now, these settings are based on my welder, what they recommend. Keep in mind, I'm running 030 wire, and that's not really designed to run on 1/4-inch plate. So with 035, the proper wire, the settings are going to be a little bit different. So on this test, got the welder fired up. Just going to run a single pass, no shielding gas or anything. So just normal like I would with flux core wire. So I can tell my settings, and I haven't cleaned it off all the way, definitely on the cold side. You see how that's roped up like that? So that's not good. I'm going to turn it up a little bit. Now, unfortunately, I only have 030 flux core wire. So 030's limit tends to be about 3/16. This is 1/4. I'll bump it up a little bit and see what happens. I went up to 19.3 and 360, which is really pushing this wire, honestly, but we'll see what happens. I'm going to keep this at full speed, but pay attention to the arc color, the smoke, and the spatter and everything so you can compare it later. Yeah, that's not really much better. I would say starting to get, there's a couple pin dots of porosity. So yeah, for 1/4-inch, I'd really need to be using 035 wire at a higher amperage, but it's looking good enough to where I think we can at least see an effect with the gas added. So I'm going to cool this plate down a little bit and we'll go from there. So I buffed these up. You can see a little pin dot of porosity at the start, a little bit right there. I mean, these don't look too bad, but honestly, this plate's a little thick for 030 wire. But we made welds, and we made at least enough of a standard to see what the gas changes, at least from appearance. So I got the gas turned on. I'm running somewhere around 22 or 25 CFH. Now, my prediction, and you can make a prediction to yourself right now, I have a feeling, I mean, there's not much spatter on this, but I have a feeling there's going to be less spatter. I have a feeling that the heat input, so the weld may flatten out a little bit. And keep in mind, I cooled this down. I soaked it in water, so it's pretty cool. It's room temperature now. I don't know. I have a feeling that there's going to be less spatter and that it may penetrate or wet out, flatten out a little bit. But I don't really know beyond that. So let's run a pass and then talk about the results. Oh, I also got to swap out my nozzle for an actual one. Almost forgot that. Otherwise, that gas wouldn't do much of anything, would it? There we go. I left this in real time. I noticed that the arc is a blue color versus white, and the spatter and smoke definitely is different. So that was interesting. It sounded different. The weld pool seemed to be more liquid, like it didn't have the fast freeze nature I'm used to. And this sucker's a little hot, but I'll bring it up. Whoa. You can see the bead appearance is different. The way that slag is in the dust looks different. I would say the bead looks flatter. Maybe not. Well, let me buff this off and come back. So let's take a look here. This was the one run with shielding gas. The first thing that jumps out to me, and I noticed it while welding, the molten puddles seem to stay liquid longer, and it has far less like variations in width and height, which would indicate, you know, a slower freezing puddle. I also noticed, and it might be hard for you to see, the bead appearance is far shinier. Like as soon as I wiped the flux off, which came off a little bit easier than these two, the bead itself was almost like shiny silver and much shinier than the other two, which honestly isn't too surprising due to the added shielding gas. Prevents, you know, that scale from building up as the steel is exposed to oxygen and reacts with it. Yeah, this angle you might be able to see how much shinier it is. Well, kind of hard to tell. It is though, take my word on it. So I'm going to run another pass on this just to get a good baseline 2 pass, and then we'll cut and etch it, see what happens. Yeah, it sounds a little different. Interesting. Huh. All right, well, I'll clean this up. So the 2 gas shielded, self-shielded wires are on the right, 2 self-shielded on the left. When you look at it, the self-shielded has a very rough surface finish, very like, not bubbly, but you get the picture. And the 2 gas shielded are very, very smooth in comparison. Like that, you can definitely see a huge difference between them. It seems to me like the weld is a little bit wider without me really trying. I don't know that it's necessarily wetted out better. You can see how humped up the first 2 are, and the second 2 are a little bit flatter. not by much, but it's subtle. Bead appearance is, I would say, better with the gas shielding. What I like about it is the lack of porosity and wormholes and stuff. I find that self-shielded wire is pretty prone to that. And if your settings aren't spot on, you're gonna get that. Well, I don't see any evidence of that at all with the gas shielding, which is also why dual shield is so popular, because it tends to produce very clean X-ray quality welds versus flux core wire. You know, you run enough of it on a job, you're gonna have a couple pin dots of porosity. It's just the nature of the beast. So yeah, I'm gonna cut this in half and etch it and come back and we'll see what we got and talk about it. Well, if the proof is in the pudding, here's the pudding. Let's take a look at this. So right away, what jumps out at me is the first pass, which was done without gas, has porosity that's clearly visible in it. I'm not too surprised at this. The settings that I was using with my welder are really a little bit on the cold side for 1/4 inch, and they don't recommend 030 wire for 1/4 inch. And I think what happened was the thicker plate pulled the heat out of the weld so fast that essentially the escaping gas was trapped inside of the solidifying weld. Now the second pass without gas, even that has porosity. You can see down at the root of the joint where the penetration's the deepest, that little white speck is porosity, and we'll see it on the other side of the plate as well that I cut and etched. Now the third and fourth pass, which I ran gas with, seemed to have less penetration than the first two. That's not what I really expected, and I cut and etched the other side of the plate as well just to get a better idea if it's just this particular area of the plate or if it's both of them. But my thoughts are, if you look at near the toe of the weld for the gas shielded, it seems to have a rounder profile, almost like the penetration near the toes is better. So it's like the overall average penetration is more consistent, but the actual depth is less. So kind of interesting. Let's look at the other side of the plate now. So I mirror imaged this so it would line up just the same as the other one. The first pass, which was done on a cold plate, you can see pretty massive penetration for not running values that are suitable for 1/4 inch. Now I increased the voltage by a little bit, and the penetration, even though the plate was hotter, really wasn't better. And you can see porosity on the second pass now that you didn't see on the first, and that's just the nature of flux core wire. Again, if I had to take a guess, I think it's just that the values weren't suitable for the thickness of the plate, and the solidifying weld just trapped that gas in there. Now, the third and fourth passes, which were done with gas shielding, again, I would say without question have less penetration using gas than without it. But the overall bead, like toe to toe, seems to be more or less consistent, or like average penetration. So a little bit more penetration out by the toes, less in the center. Not what I expected. Again, no evidence of porosity on the gas shielded at all. So that's interesting. Now here's both of them side by side. Yeah, it's pretty interesting how in one section you can have no porosity, and then in another one, just a millimeter ahead, you have a bunch. That's just the nature of it. Yeah, based on this short, small scale testing, I would say that running gas shielding with C25 will actually limit the penetration, but it does give you a reduction in probable porosity, at least based on what I'm seeing. So those results were a little bit different than what I had expected, to be honest with you, but then again, I didn't come into this video with high expectations anyways. But yeah, the gas shielded welds, better appearance overall, no evidence really anywhere on them of porosity, and you saw in the cut and etch that these two that were self-shielded did have porosity. Now, like I had said in that kind of up close and personal part, I think that a lot of that porosity simply because that molten metal solidified so fast because the settings weren't hot enough for this plate that the gas simply didn't have enough time to escape that molten pool, therefore it was trapped inside. Had I ran 035 wire at higher values more suitable for 1/4 inch plate, I think that that would have all cleared up and it would have had even more penetration than what we saw there, which, you know, it had plenty of penetration. Flux core wire is great for that. But yeah, I don't know, what are your thoughts on this? Is it what you expected? Would you ever consider running shielding gas? I mean, my honest opinion is, and take it with a grain of salt, that if I wanted to run dual shield, I would go pick up 035 dual shield wire from like ESOB or something and run suitable wire. But I guess in a pinch, would it work? Yeah, I mean, really all you're doing as far as I'm concerned is lowering your probability of having wormhole or porosity in it, but beyond that, not really much of a difference. So I definitely wouldn't do it simply because the cost of the wire plus the gas means it's very expensive. You know, I'd rather get different wire or something, or, you know, I don't know. Anyways, thanks for sticking around. Hopefully you learned something. I know I did. Till next time, guys.